Yeah, I think a lot of us have, unfortunately.
Mm-hmm. All right, let's see. Can you read that okay?
Yes, I can.
Okay, we got through number 7 last time on solid geometry, so let's pick up with 8.
Okay. Okay, so I'm looking for volume, which would be 10 times 5 times 20.
Correct.
So let's see, that's so 1,000 centimeters.
Okay. 1,000 cubic centimeters.
Yes.
Okay.
So let's see, if the tank is half full of water. Okay, well, if it's half full of water, then it's got 500 cubic centimeters of water in it already.
Okay.
And if we add 325 more, see, I don't know what I'm doing wrong, because to me that would be 825 total.
Okay.
Wouldn't it rise 325 cubic centimeters?
It would, but they want to know the new height of the water. In other words, how much does the water level rise, which is the distance between there and there. If you can see that. In other words, it doesn't go all the way to the top. You'd have to add 500 cubic centimeters for it to go all the way to the top. So we know it goes somewhere between 10 and 0 centimeters up. So what is the new height dimension? In other words, originally when you drew this, it was a 10 by 5 by 20 was the height of the tank.
So we went from 20 centimeters
to some new, we weren't at 20, we were actually at 10 when it was half full.
Oh, okay.
In other words, this level here is 10 centimeters up from the bottom. From there to there is 10. And they want to know how much it rises when you add 325 cubic centimeters to it.
You know what? I'm not quite sure how to figure that one out.
Okay, what's the new height? In other words, if I told you that there was 1,000 cubic centimeters in there, and that it had a base of 10 by 5, what would its height be?
Well, it would be 20.
In other words, it would be 1,000 divided by 10 times 5, right?
Uh-huh.
Okay. So our new height we're looking at is 825 cubic centimeters. So if we divide that by the base and width of the tank that haven't changed, we'll get the new height.
And you know what? That's not one of the answer choices, 16.5.
Well, that's because they ask how many centimeters will it rise. So if it's going to go to 16 and a half and it started at 10, it's going to go up by 6.5. Hold on. Let's see if I can get my dog calmed down. Quiet, come here. Quiet. What are you barking at? garbage truck day. I think she probably hears stuff that I don't hear. She's always barking, and I don't know what she's barking at because I can't hear as well as her.
I know, my dog does the same thing.
Yeah. Okay, that's actually the hard way to do this problem. Not really the hard way. We have to take this approach, but there's a bit of a shortcut, and that is that when you recognize that the height is the volume divided by the base times the width. In other words, we started out with volume equaling base times height times width. Well, that makes the height equal to the volume divided by the base times the width. And the base times the width don't change. So if we want our height change, then we just take 325, the amount that we're adding, and divide it by 50. And that gives us the direct answer immediately, 6.5. Turn my camera off. My computer is telling me my audio quality may be compromised, so the first thing I'll do is turn my camera off. Okay. So I would have done it the hard way, I'm afraid, when I did it, by doing it basically the way you started out doing it, assuming that, knowing we had 500 and we're going to add 325, so now we have 825. Then I would have figured out the new height of the water based on 825 and figured out the difference between that and 10 inches or 10 centimeters. So this right here is most direct. That's a 15-second solution. But it's necessary to do these two steps in order to be able to even think of that. But you have to do these two steps regardless. In other words, even to solve it the hard way, we need to come to this conclusion right there, that the height of the water is equal to the volume divided by the base times the width.
Okay.
All right. The height of the cylinder is 4 times its circumference. I can make this just a little bit bigger. Yeah. This is another problem where they love these problems, where you have a couple of formulas that are functions of variables, and they want you to switch up the variables and tell them, what we know what the formula for the volume of a cylinder is based on radius and height. So they're asking us to do algebra, essentially, on all of these problems. So let's spell out what we know. What's the volume of a cylinder?
It's pi r squared times the height.
They've told us that the height is 4 times the circumference. So there's everything they've told us. Okay, and they want volume in terms of circumference. Well, the very first thing I can do is this. So we're closer. But notice that radius isn't in any of our answers, so we have to solve for radius too. What's the other thing we know? I didn't list everything we knew here. What is circumference in terms of radius?
Okay, circumference is 2 pi r.
So now we can solve for radius in terms of circumference and substitute that for there.
Okay, so c divided by 2 pi.
So there's our thing. And you see the common element? We actually started with 3 formulas, and this formula is in terms of r and h, and so we need r to be in terms of c, and we need h to be in terms of c. And then we'll be able to solve for v in terms of c. Let's simplify this, because this undoubtedly is not going to be their answer. So that's pi c squared over 4 pi squared times 4c. What does that give us?
We'll multiply both sides by 4 pi squared.
Well, we're just looking at an expression here. We're not looking at an equation. Well, you're right. We are looking at an equation, but we're looking at an equation that just needs to be simplified.
Okay, and we can eliminate one of the pi's, the upper.
Can eliminate that 4 and that 4. So what do we have left? C cubed over pi. A. Okay, good with that?
Yes.
All right. We have 3 tennis balls that fit perfectly in this can. The radius of the ball is the same as the radius of the can. Balls go from bottom to top perfectly. They want the ratio of the volumes of the tennis balls to the volume of the can. What ratio of the can is taken up by the volume of the tennis balls?
Okay, so the radius of the spheres equals the radius of the can.
Mm-hmm. So let's spell out what we're going to need to know. What are we going to need to know? What are they asking for? What expression is it that they're asking for?
I don't know.
Well, it's the volume of the 3 balls divided by the volume of the can. So let's start there. That's what we're looking for. Let's start with the volume of 1 ball. What's the volume of a sphere?
4 divided by 3 pi r cubed.
Okay. That's pretty good, because that's the same r as it's the radius of the can. So what's the volume of the can?
Pi r squared times the height.
Correct. Well, we want to get all of our variables the same. In other words, this isn't going to help me answer my question until I can get rid of the h. What is h equal to? Preferably in terms of r, because if I can make h a function of r, I can substitute it for here and then answer the question directly.
I'm really having a difficult time with this one.
Okay, look at this can. How many radiuses make up the height?
6.
So h is equal to 6r.
Okay.
Okay, so now I can go back up here, and the volume of one ball is this, so the volume of 3 balls must be 4 pi r cubed. I'm going to divide it by the volume of the can, which is pi r squared times h, which is 6r. Now, a lot of nice things are going to happen. We've got r cubed here, we got r cubed there. We got pi, we got pi.
Oh, wow.
4 divided by 6, but you would need to put 2 divided by 3, I'm quite sure. But no, in fact, you told me that you didn't need to do that, huh?
No, you don't. They said as long as you have it in the correct ratio, that you don't have to have it in the lowest terms.
Yeah. I think one of the keys to this problem is starting at the back. And in fact, it's a key to a lot of word problems. Rather than trying to figure out how to go about answering this, let's start with what they want. What fraction of the volume of the can is taken up by the balls means the volume of 3 balls divided by the volume of the can. So if you start there, the problem kind of unfolds and its solution becomes far more doable.
That makes sense.
This was a tough one, but not that tough. The key really was recognizing how to relate the height of the can and the radius of the balls. Okay. Jack and Jill. Actually, I got these drawn wrong. I should have the one on the, I should have them reversed because quantity A is the volume of Jack's cylinder. In other words, Jill rolls her, they both roll it from bottom to top. Who has the bigger volume?
Isn't the volume still going to be the same?
You know, oddly enough, that was my first instinct also. And then I realized a fundamental math problem that actually allows me to solve this without doing the math. First of all, let's do the math.
Okay.
What's the volume of Jill's going to be?
It's, let's see, if she folds it in half, then the radius is going to be 4.5 squared. Did I not do that right?
Well, if you're correct that she's going to fold it where it becomes a thinner tube. Jack's going to fold it where it becomes a thicker. In other words, Jill's is going to be a higher cylinder. Jack's is not. What is the... You're on the right track. You want to solve for radius. But if Jill's, what is the circumference of her tube?
Well, let's see, since she's taking the 12-inch edges together.
isn't the circumference going to be 9?
Okay.
And circumference is equal to 2 pi r. So you were close. R is going to be 9 divided by 2 pi instead of 9 divided by 2. So her volume is pi r squared is 9 over 2 pi, quantity squared, times h. What is her h?
12.
Jack's volume. What's Jack's pi? I mean, what's his radius, rather?
It's going to be 12 divided by 2 pi squared.
And his height is?
9.
So the question is, which number is bigger, that or this? And they're not the same. Let's see, let's do the math here. This becomes pi times 81 over 4 pi squared times 12. This becomes pi times 144 over 4 pi squared times 9. Well, the denominators are the same, so we merely have to compare the numerators. The question is, what's bigger, 9 times 144 or 12 times 81? 12 times 81 is 972, and 9 times 144 is 1296. So Jack's is bigger.
Yeah, I definitely would have guessed on that one wrong if I would have guessed.
Well, let's talk about this principle, because there's actually a pretty cool principle at play here that allows you to answer this without doing any math. And that is that if somebody gave you a certain amount of fencing material and they said, make a rectangle out of that fencing material to maximize the area, because I got horses I want to put in there. The shape, if you could do the calculus, the shape is a square. It's not a rectangle like this. In other words, both of these figures have the same perimeter, but the square has the bigger area, always.
Oh, okay.
Same thing with if they gave you a certain amount of fencing material and said, give me the maximum amount of area, it wouldn't be a square, it would be a perfect circle. That's why circles are the perfect shape in the universe, is because you get the maximum amount of area given the circumference. And that's also why spheres are what all planets go into, pretty much. It's why. So what I'm trying to say is that if you shape a cylinder that is closer to looking like a sphere than an egg, if you say which cylinder is going to have the biggest volume, given in our case that they have the same perimeter, essentially. It's not quite the same thinking as perimeter, but if you understand what I'm saying here, if I wanted to build a paint can with a minimum amount of surface material, I would build it in this shape, not this shape.
Okay.
because this is closer to a sphere or a square, if you will.
Right. And the other one's closer to a rectangle.
Well, yes, an elongated rectangle, yes.
Right.
So the two things to remember is that these don't give you the same, that the object that is closest, where the outside of it is closest to a center, a focus, is the one that gives you the most volume. So if you think of this and you look at the original drawings here, you can see that this gives her a long, narrow tube. This gives him a shorter, fuller tube. So this is the one I would pick immediately.
Okay.
Based on that. It's actually a classic calculus problem, is to prove how a manufacturer should design a beer can.
Oh, really?
Yeah, because the manufacturer's cost is the material, the aluminum that you make the beer can out of. So you're given a certain amount of aluminum, you want to make as big a beer, in other words, you want to use as minimum amount of aluminum in making your beer can that holds 1 liter of beer.
Right.
And it turns out that it's the same height as the diameter, is the optimum. All right, let's look at 12.
I'm going to say they're equal.
Okay. The
Because
math is so easy to do here that before you jump to that conclusion, let's do the math.
okay, because yeah, I was going to say the way I was looking at that was a volume of a cube is edge cubed, so 6 times 6 times 6. And yeah, 5 times 6 times 7.
Now, even without doing a calculator, I know this is bigger because 5 times 7 is 35, and 6 times 6 is 36.
Okay.
But given that you can use calculators, there's no reason to guess on this or try to find that shortcut. It's not like the previous problem. This problem, there was a lot of math involved in doing that. And it took maybe 1.5 to 2 minutes to do all that math. So there's a lot of value in knowing that other for 11. But for 12, 6 cubed versus 5 times 6 times 7.
Okay. Okay, so the area, let's see, A is the surface area, which would be length times width times height. And then volume would be 2 times, the volume would be bigger.
What's the surface area again?
Surface area, maybe I'm doing that wrong. Length times width times height.
That's the volume.
Oh.
In other words, volume is length times width times height. But surface area, if we look at this cube here, which is actually for a different problem, but if we look at this rectangular box, notice the surface area is 2 of these plus 2 of those plus 2 of the top.
Yeah, I had them backwards.
To 2LW plus 2WH plus 2LH. In other words, it's 2 of each combination.
Right, so the surface area is going to be bigger.
Well, surface area, if L and W were, L, W, and H were all 1, the surface area would be bigger. What if L, W, and H are all 100? In other words, if L, W, and H are all 1, the volume is 1, clearly the surface area is 6. So in that case, surface area would be bigger. But let L, W, and H all be equal to even 10. And then the volume is 1,000. And up here we have 200 plus 200 plus 200. That's only 600.
Okay, so it can't be determined.
Exactly. Now, without picking numbers, it's not absolutely clear, obviously, that when you look at this, that you can tell which is bigger. We could factor a 2 out. Does that help? So the question becomes, what's bigger, LW plus WH plus LH, or L times W times H? And it depends on the numbers. You can't tell from looking at that equation which is bigger. There's no way mathematically to know. In other words, I can't say LW plus WH plus LH is greater than or less than LWH.
Okay.
Don't know. But the best way to prove that is to pick some numbers. And when you're picking numbers like that, my first inclination was to try some fractions, because I knew if I tried fractions, this would get smaller. If I picked my L, W, and H being numbers less than 1, the volume's going to shrink. But it turned out that using 1 was the perfect number, and then using 10 was also an easy number to work with. So the key in that situation when you pick numbers is pick numbers where you can do the math quickly. Okay, 14.
Boy, I am just not doing good on any of these today.
Well, these are hard. These are hard. Solid geometry has always been the hardest math discipline for me. I'm good in 2 dimensions, but once I get in 3 dimensions, I'm not so good. Well, what's the area of that triangle?
Well, I know AB is 1.
Let's start with that.
Okay.
So the base of the triangle is what?
The base would be 1. Yeah, 1.
So the question is the height would have to be 2 in order for these two quantities to be equal, right?
Yes.
Can it be 2?
No.
No, it can't be. Notice that if I were to take a journey, if I was an ant, and I took a journey and I went this way, I went straight down that face and straight across, that would be 2. This clearly shortens that distance to get from this point. In other words, we're trying to measure the altitude of this triangle. So we're trying to go from there to there. And the question is, can it be 2? No, that's the shortest distance between those 2 points, and we just took a longer route that was 2. So this height has to be, without doing a lot of math, it has to be less than 2, and that's all we care about. I don't want to get involved in the math of solving for that height if I can avoid it.
Yeah, I'm really glad you're showing me these, because a lot of times I solve for I mean, I actually do try to plug numbers in and everything, and it takes a lot of time.
Gosh, I'm trying to figure out, I guess, do we know that's a 45-degree angle? Possibly we do. So figuring out this actual height of that triangle is doable, but tough geometry. Whereas this method here really makes the problem a lot easier and avoids having to do the math.
That makes sense.
Okay, let's see, we got one more. The volume of a sphere whose radius, oh well.
Okay, the volume of a sphere would be bigger. Wait a second. Yes.
Good.
The volume of a sphere is 4 divided by 3 pi r cubed.
There's r of a sphere. Here's r. I'm comparing a circle with a square, but it's really easy to see that the circle is going to be a lot bigger.
Right. Once again, without doing math.
Without doing the math, yeah. So making this a sphere and making this a cube doesn't really change that. You could easily put this cube inside the sphere, mainly because the sphere has a width of 2r, whereas the cube only has a width of r.
Okay, that makes sense.
Yeah. But the math wouldn't be that hard to do either. This is 4/3 pi r cubed. This is r cubed. Well, 4/3 pi r cubed is clearly bigger than r cubed. Okay, enough with solid geometry. Coordinate geometry. Surprised they put them in this order, because to me, coordinate geometry is a lot easier because it's only in 2 dimensions, for one thing.
Yeah, I definitely need help with this too.
Well, it's different math is what it is. Coordinate geometry is very much about slope. Not so much solid geometry. We didn't have to deal with slope once in any of those questions on solid geometry. Okay.
And this I actually know how to do, slope, because it would be y2 minus y1 divided by x2 minus x1.
Okay.
So 0 minus -2 would be 2, and then 3 minus 0 is 3, so it'd be 2/3.
Good. Probably is going to be useful to you to draw your pictures, and always, you don't need to label it, but put the XY coordinate axis up there. Okay, this is point R. Now this I'm not sure if all of this is worth the time that you have to do it, but in this case probably is. So here's our triangle. They want the sum of the slopes. Well, what's this slope here?
Wouldn't that be, except that I don't know which one's what. I don't know.
What's the slope between the points 2, 5 and 0, 0? In other words, it's the same as question 1.
Where I'm confused though is, how would I know which one was y2 and y1 and x2 and x1?
It's actually better to remember slope as being rise divided by run. Because it doesn't really matter whether you do this or this. You get the same number. So if I'm trying to figure out the slope of line RT, well, what's my rise? My rise is 5. My run is 2.
Okay.
So 5 halves. And y sub 2 minus y sub 1 is 5 minus 0, 2 minus 0. Okay, so using that, let's go through and find the slopes of all 3 sides of this triangle. What's the slope of this?
Going to be 1. No, wait.
Remember, it doesn't matter which way you go, just be consistent. You can do 5 minus 0 over 2 minus 7, or you can do 0 minus 5 over 7 minus 2. Either way, you get a negative 1. And it's a good idea to check to make sure that the sign on the slope agrees with what you're looking at. We can tell that that's a negative slope and that this one's a positive slope. What's the slope of the third side of the triangle?
It's going to be 0.
What's the sum of those 3 numbers?
3 over 2.
Correct, which is 1.5. Okay?
Okay.
Okay, I'm going to leave my grid up here because all of these problems are going to be based on points on the grid. A is at minus 1, 1. You're good with plotting points? No problem with that?
I believe so.
Okay.
I haven't been working on this a lot.
Okay. How do I plot B?
B would be 3 horizontally.
To the right.
Yes, to the right, and then down 1.
Okay, so we'll put B there. And notice that it's not going to matter a whole lot how accurate I draw these. I generally just estimate. In other words, this is a pretty good estimate. This distance here is about equal to that distance. And what I was trying to do here was to make this distance about 3 times that distance. Or this distance here 3 times that distance. And that's all I care about in terms of being accurate. I'm going to have to use math to do this, not anything else. Okay, so that's the endpoints of one side of a square. So clearly the square has two possibilities. This is one, and the other way is one. What is the area of the square? Well, it doesn't matter, does it? Which one I use. The area is going to be the same, so we'll use the one that, this one here. So what do I need to find?
You need to find one of the sides.
The length of one of the sides.
Right.
So this is the distance between 2 points. And there's a formula. It's called the distance formula. And the way to remember it is it's actually the hypotenuse of this triangle. So what would the hypotenuse of that triangle be? Starts out with square root, right? Because whenever you're solving for any side of a right triangle, it starts out with square root. It's always square root of something. So what is it the square root of?
I don't know.
Okay. Well, since the Pythagorean theorem applies, it's the square root of the sums of the square, the sum of the squares of each side. Well, notice what this length is the difference in the x-coordinates. So that's x sub 2 minus x sub 1 squared. And this distance here is the difference of the y-coordinates. So there's your distance formula. And this is something you want to memorize. Hold on, then my TV just, let me mute it. I forget that I pause it, and then I remember it only has like a hour thing on there where it goes off on, it can only store an hour. So you need to know the distance formula for sure. It's just, this thing looks like a brute to memorize, but it's not if you remember that c is equal to the square root of a squared plus b squared, where a is the lengths of the sides of the right triangle. So in our case, a is x sub 2 minus x sub 1, and b is y sub 2 minus y sub 1. And I don't mean points A and B on my diagram, I mean in the Pythagorean theorem, C, A, and B. I'm a firm believer in memorizing the least amount of information possible so that you can always work it out. In other words, I don't really memorize that. I derive it with the Pythagorean theorem always. Eventually, it makes its way into my brain and I memorize it. But so the question really becomes is, did we need to draw this elaborate picture? And not really. If we would have read the problem, we could tell that it's a distance between 2 points kind of problem. That's a very common question on all geometry tests. Distance between 2 points on the xy coordinate. So, I don't know. We didn't come up with an answer, but do we need to?
I think so, because, well, So it would be 3 minus -1, so 4 squared plus -1 minus 1. No, yeah, 2 squared. No, I got it.
Okay, so what is that? 16 square root of 20. So the area of the square is that squared, which is 20.
Okay.
Okay, the area of the circle above is k pi. What is the value of k?
Okay, so area is pi r squared. So set k pi equal to pi r squared?
So k must equal r squared. So what is the radius of that circle?
The radius is 3.
Remember in coordinate geometry, the points, that's 3 on the x-axis and 3 on the y-axis. This is the radius. So this is 3 and this is 3. So I need a radius that's not 3. You see why 3 isn't? In other words, 3 is the measurement from here to here, and 3 is also the measurement from here to here.
Okay.
So the radius of the circle is actually from there to there. So I need that side of a 3, 3 triangle.
And since it's an isosceles, I would have thought it would be 3 root 2.
Perfect, without doing the math, without having to do the Pythagorean theorem. So if that's the radius, what is k?
Let's see, square it, so that would be 18.
Good. See, now I can hear the garbage trucks myself, and my dog is quiet. What's going on? She must be barking at something else. Okay. If P and Q are 2 of the vertices of a rectangle, which of the following could not be another of the vertices? Well, this looks to me like it definitely might require a picture. Okay, so 2, comma 1. First I go 2 to the right and then up 1. There's 2, comma 1. And 8, comma 1. Well, we'll call that 8, comma 1. Same height, further out to the right. That's the vertices of a rectangle. So this can be something like this, or again, something like this, and that's it. No, it could be something all the way down to there also. Okay, so first thing right off that we should notice is that the y-coordinate on these points has to be the same. And let's just do back solving here. Let's examine some points here. 2, comma 8. 2, comma 8 could be this point right there, right?
Yes.
Okay, so that could be 8, comma 2. Well, that would be a point right there. Could that be?
Yes.
Okay. 2, comma minus 8. That's some point down here.
Yes, it could be.
minus 2 comma 8. Minus 2 comma 8. Could it be that point there?
No.
No, it couldn't be. That would have to be a parallelogram if that was. In other words, if we drew something like that, then it would be a parallelogram with our figure. It wouldn't be a rectangle. So minus 2 comma 8 is it. And clearly it could be 8 comma 8, which would be that point there. But you don't need to go through all of them. Once you find one, you're done. And I think back solving actually is the best way to go there. And drawing a little picture.
Yeah, that helped.
I'm not real sure if there's another technique besides back solving, in fact. Okay, a circle with center being at 6 comma 8. Now, the only thing about my drawing that I want to make sure is that the height is greater. I didn't put that point right there to make sure that this height is greater than this distance, the x-coordinate.
Okay.
Passes through the origin, so there's its radius. So the circle, somewhere like that. I should have drawn it on my screen, so that, let me do this. Draw a circle, passes through the origin. To the following points is not on the circle. Do you know conic sections?
No.
Have we ever talked about conic sections?
Huh.
We've never talked about the equation of a circle.
No.
Well, the equation of a circle is, I'm not convinced yet that you need this, but just to let you know, where h and k are the center of the circle, and r is its radius. So the equation of this particular circle is x minus 6 squared plus y minus 8 squared equals, well, if that's that must be 10, huh? If I try to figure out that radius, and it's a 6, 8, 10 triangle. So there's the equation for this circle. Now, for a point to be on the circle circumference, it has to fit this equation. In other words, does 12 comma 0 fit this equation? Well, it does. 12 for x gives me 36 here, plus 0 for y gives me 64 there, and it does equal 100. So that's the mathematical way to do it.
That's good to know.
Yeah, it's definitely good to know. However, let's see if we can figure this out just by back solving, if you don't want to rely on the math here. Let's examine some of these points. Maybe we'll be able to figure out, just by looking at it, draw this slightly more accurate, because the way I've drawn it, the x measurement's bigger than the y. So in effect, let's see, if I make the center right there, it goes through the origin, That's a little bit better in terms of trying to figure out whether these points might be on the circle. 12, 0. Well,
It looks like it can fit.
yeah, because if I went, this is at 6, and if I go to 12, now it curves. So could that point be 12, 0? Maybe. Maybe. About 6, -2. Well, that could possibly be on. How about 16, 8? Well, 16 goes way over here.
So no.
Yeah, that's not, can't be on there. Just vision. So we were able to answer it without knowing that equation. Good.
It's still good to know the equation.
Well, I tell you what's good to know is that when you have an equation of a circle, what it means is that any x and y point being on the circle means it's on the circumference, and both of those points have to fit that equation. That equation has to remain an equation when you plug in the points x and y.
Yeah, I like that. That's nice.
Okay. Again.
And you know what? It's after 10. Did you want to go ahead and...
It is. Yeah, no, let's pick up from question 7 tomorrow.
Okay.
Thanks for reminding me. I got carried away.
Hopefully I'm on my game a
I'm not
little bit
doing
more.
much math, so I'm loving getting back into it. I mean, I'm not doing much tutoring. I've had a bit of a break here.
Well, that's probably good, though, too.
Oh, it is. It is. It definitely, giving your mind a break from math is helpful. But sometimes it takes me a while to get back into it. And it's always fun, though, for me.
You make it fun. You make it understandable.
Well, good. I'm glad. Okay, I will talk to you at 9 tomorrow morning.
It sounds good. Thanks, David.
All right, bye-bye.